Hello, I'm Dave Brown, and today our subject is conveyors and conveyor components. Our emphasis will be on the four most common types. First, there are belt conveyors. Then next, there are screw conveyors. Here you see bucket elevators. And finally, roller or skate wheel conveyors. Now, let's examine each of these common types individually so you will better be able to understand the conveyors and their components. We'll start with belt conveyors. The first recorded use of belt conveyors was in 1795 in the grain industry. Since that time, they've come into wide acceptance throughout industry, and they are used to convey practically every material that can be handled by a conveyor. What is a belt conveyor? In its simplest form, it's two pulleys around which we wrap a belt, like this, and with some type of drive as indicated. The original belts for belting conveyors were either leather or a woven cotton fabric. Later, this fabric was rubberized to give it more life and more resistant to moisture penetration. And then still later, a rubber coating of various thicknesses was bonded to the rubberized fabric on top and bottom. More recently, synthetics of various types have been used, particularly nylon and rayon. Also, various coatings other than rubber have been applied. The material to be handled dictates the particular type belt to be used. For example, special coating materials are required for oily, hot, or sticky materials. As indicated in the sketch, the simplest type of belt conveyor consists of one head pulley, this can be called a drive pulley, one tail pulley, and a belt. The belt connects the two pulleys and runs completely around. The head pulley is a drum, which is bored for a shaft. This shaft is supported by a bearing on either end. The pulley may be flat, which means it is flat across the surface, or it may be what is known as crowned. This means there's a slight taper from the center, here, to each end. Now, it's normally tapered 1/32 of an inch to 1/8 inch per foot of width, depending on the manufacturer. This taper or crown helps to keep the belt in the center of the pulley. When we guide the belt to make it stay in the center of the pulley, it's called training the belt. To expedite this training, there are special idlers made, which are appropriately called training idlers. The head pulley may be either steel or cast iron. It may be used as machined, have a mechanical finish, or it may be lagged. Lagging means a rubber covering of some sort is attached to the pulley. This attachment may be accomplished by vulcanizing or gluing the rubber onto the pulley. The reason for this lagging is to provide a higher coefficient of friction between the pulley and the belt, which means there's less tendency for them to slip. Now, tail pulleys are usually similar to the head pulleys. However, there is a pulley used for certain applications where there is a tendency for buildup on the pulley, or where the material may be trapped between the belt and the pulley. It's known as a winged pulley. When any material falls on the pulley, there's an opening which allows the material to move out the end. These are most frequently used as tail pulleys on elevators and inclined conveyors. As the belt conveyor becomes longer, some additional support is going to be required in the middle. This is done with idlers. These are cylinders of steel and are normally 4, 5, or 6 inches in diameter. The length of the idler is determined by the belt width. They have a bearing in each end, and these bearings may be either ball or roller bearings, depending on the load the conveyor is to handle. The idlers are spaced every few feet along the belt and this spacing is also dependent on the load. Idlers are placed on the return side of the belt, but because there's no load other than the weight of the belt itself, they are spaced further apart. Today, in most applications where bulk materials are handled, we use an idler like this. It's called a troughing idler, and they are furnished with either 20, 35, or 45 degrees taper on each side. This one is a 35 degree. This tends to make a trough out of the belt, which allows it to handle more material, particularly if the material has a low angle of repose. Now, angle of repose is a term we need to talk about. Angle of repose is a term used to indicate whether the material tends to stand up in a peak when it's piled up, or whether it tends to flatten out. If the material stands up with a relatively high peak, something like damp sand, then it's said to have a high angle of repose. If it tends to flatten out, like wheat, it's said to have a low angle of repose. As you can see, the troughing idlers are actually composed of 3 short, separate idlers which are used in conjunction with each other. They are held in what is known as a stand. In addition, we have the impact idler, which allows large shock loadings to be absorbed. These are normally found in places like a rock quarry, where heavy rock is dumped on a conveyor and would damage normal idlers. The next point to consider is a drive for the conveyor. It's frequently a shaft mount. In this case, a shaft mount reducer is mounted directly onto the head pulley shaft, and this in turn is driven by a V-belt from a motor. The drive may be a direct chain drive from a reducer, or there may be a jack shaft with V-belt and chain drive. A jack shaft is the name given to an intermediate shaft, as you see in this sketch, this one here. Which type drive system is used depends in a large measure on what the speed of the conveyor is to be. Normally, the drives are relatively low speed, but actually, the speed of a belt conveyor is only limited by the centrifugal force, which reduces the contact with the drive pulley as we reach high speeds, or if the belt is moving so fast that the air actually blows the material off the belt. Normally, belt conveyors travel at 800 feet per minute or slower. In order to keep the belt conveyors tight, there is some sort of take-up necessary because there will be a change in the length of the belt as it's used. It is therefore necessary to have a take-up, and these are either screw take-ups like this or gravity take-ups as shown in this sketch. As you see, this weight hanging on the belt keeps it tight. Next, we need to consider the loading and unloading of the conveyor. Normally, we try to have the material traveling in the same direction and at approximately the same speed as the belt conveyor when it's deposited upon that conveyor. Now, special consideration must be given to loading and unloading if we're handling lumpy material or very fine material or sticky material. The question should be asked as to whether the conveyor will have a housing or not, and this will largely be determined by the environment. Finally, there must be a frame or superstructure to support the idlers, the pulleys, and the drives. This frame is normally composed of welded, fabricated structural steel. There are several different configurations a belt conveyor may take. They may be flat or inclined up or down. Now, with conveyors inclined, in order to keep the material from rolling back down, it's sometimes necessary to have either a rough top belt or even slats, which may be bolted or molded onto the belt. Next, we'll discuss screw conveyors. The screw conveyor is composed of a screw, shaft, couplings, trough, hangers, trough ends, together with bearings, loading and discharge spots, and finally the drive. Now let's look at these components separately. The screw is first. The screw is a helix which is wound around and welded to the center shaft. This helix is normally cold formed from steel strip in one continuous piece. The cold forming process gives a cross section which is wider at the base here, where it's connected to the tubing, and thinner at the outer edge here. This process of cold working makes for a harder, tougher steel. In addition to helical conveyor flighting, most manufacturers make what is known as sectional flight screw conveyor. This type is fabricated one pitch at a time. These are then welded to a shaft and to each other to make a continuous screw. The shaft is steel tubing. Various thicknesses of tubing are available. One pitch in conveyor is the distance from this point to this point. On standard screw conveyor flighting, the diameter of the screw is equal to one pitch. In other words, a 9-inch diameter conveyor would normally be a 9-inch pitch. For certain special applications, there are a number of other types of special screws. For example, if accurate delivery is desirable, there is double pitch, which has two helix running around the center shaft. There is cut flight, which is used when it's necessary to mix or stir the material being handled, and this is called ribbon and is normally used on sticky type material. Since screw conveyor is normally manufactured in 10-foot or 12-foot lengths, it must be coupled together. The coupling is normally either a short section of larger tubing and will slip over the outside of the shaft and is pinned together with a bolt, or this style, which uses a rod which is inserted into the shaft ends and then bolted into place. The trough is either a U or V shape. If it's a V shape, as you see here, it has a rounded bottom V and may or may not be covered. It is normally fabricated from sheet metal, and if it's covered, it will have a gap in the top for the loading spout. The discharge spout will, of course, be attached to a hole cut in the bottom. The trough ends are either steel or cast iron and have a bearing mounted in the center. These bearings may be either ball, roller, or sleeve, depending upon the material to be handled. They must be able to take the thrust which the screw transmits to the trough ends. That is, unless the bearings in the reducer absorb the thrust. If the conveyor is more than one section long, the unit must have hangers. These are T-shaped brackets that have bearings on them. The bearings usually will be either sleeve or ball. The drive is frequently a shaft-mounted reducer, as you see here, but can be either a parallel or worm reducer, which may be direct coupled or chain connected to the conveyor. One thing which should be taken into consideration: if possible, we want the conveyor drive mounted on the discharge end, so the shaft itself, which tends to be limber, will be in tension, and the bearings in the reducer can be used to absorb this thrust. Like the conveyor belts, the screw conveyor may be horizontal or inclined, and more recently, there are a number of applications where it is actually vertical and used in place of an elevator. This application is frequently found in the grain and feed industries. Now next we come to bucket elevators. What is a bucket elevator? Well, it's a method of lifting some material from one elevation to another. Buckets are mounted on a continuous chain or belt, and these are pulled through the material that's to be elevated. There are three basic types: centrifugal, continuous, and gravity discharge. Centrifugal is where the material is actually slung out at the unloading stage. Continuous is where the buckets are overlapping, so the bottom of one bucket serves as a discharge area for the bucket immediately above it. The gravity discharge, as you see here, allows the material to come back over and be dumped out or fall out by gravity. The gravity discharge is normally slower than the other two types. On the chain type elevator, the attachment chain is used. There are many styles of the attachment chain, and we simply bolt a bucket onto the chain. Here are several different types of standard buckets. Now, we can use either single chain, where the chain runs down the center of the bucket, or it may be double chain, where a chain is bolted to each end of the bucket. On a belt bucket elevator, flat woven belting or sometimes standard transmission belting is used, and in either case we must use a special wide head bolt, simply so the bolt head won't pull through the belting. Each elevator has a head pulley at the top and a tail pulley mounted at the bottom, and a take-up either at the head or tail pulley so the belt may be kept tight. These two pulleys have shafts and are mounted on bearings much like a belt conveyor. In fact, an elevator can be termed a flat belt conveyor, which has been turned up on its end and has buckets attached to the belt so the material won't fall off the belt. The drive is very similar to the types used on regular belt conveyors and is normally mounted on the top. An elevator almost always will have a housing, since the buckets are loaded at the bottom. Since they're normally quite full, there is usually some material falling back all the time. It's not unusual for the tail pulley to be a wing-type pulley for this specific reason. The next type of conveyor to discuss is the roller or skate wheel conveyor. These are usually gravity and most frequently are manual. They're widely used at loading and parking stations. They can be live roller. Live roller means there's a drive mechanism, and this turns the rollers either with a belt on the top or bottom of the rollers. The rollers themselves may be spaced very close together or wider apart depending on the weight of the material to be handled and the size of the bottom of the box. If the product to be handled is small, it may be necessary to put it on a pallet. On a roller conveyor, the rollers themselves are nothing more than steel cylinders which have a bearing mounted in each end. These bearings are usually non-precision type, since individually they carry very little load. The rollers are mounted so that a relatively flat surface will be presented to the material, which has to be pushed over them. By setting the rollers at an angle, the boxes can be made to go around curves. This allows us to make up systems in a number of different configurations. In addition to roller conveyors, there are skate wheel conveyors. And these are composed of a series of wheels similar to those used on a child's roller skate, and they present a similar flat surface. Since they're spaced relatively close together, as with the roller conveyor, this allows us to move material along the work area and then into a storage area with relative ease. Skate wheel and roller conveyors are made up in sections. Sometimes they're mounted on casters for portability, and so they may be moved easily from area to area. An example would be in a truck loading area. These conveyors are usually made up in 10-foot lengths and in varying widths depending on the width of the material to be handled. It's not unusual to see more than one of the different types of conveyors being used on a single job. For example, for packing or intermittent storage, a belt conveyor may discharge onto a gravity roller conveyor. Or we might see a belt conveyor being fed by an elevator or a screw conveyor. One fairly common type of belt conveyor is the one we see here, the slider belt conveyor. In this case, we slide a piece of belting along a metal table. This allows us to have support all the way along the belt. These are frequently used in the food industry, as we're showing in this film. In addition to the conveyors mentioned, there are a number of other types. Probably the most common of those which I haven't discussed yet is the overhead chain conveyor. This is where a hook hangs down from an overhead chain. This chain is in turn suspended from rollers mounted on an I-beam rail that runs throughout the plant. There are also various types of drag chain conveyors which use the chain itself as the medium for the material handling. There are various types of cable conveyors where wire rope is used, an application similar to overhead type conveyors, except here the wire rope is used instead of chain. There are systems which use chain that's installed in grooves in the floor, which in turn pull wheeled carts. Now obviously we can't cover the hundreds of different ways available for conveying materials, but hopefully we have provided some insight into the four most common types. And again, those four most common types are the belt conveyor, the screw conveyor, the bucket elevator, and the roller or skate wheel conveyor. I'm Dave Brown for Tel-A-Train.